different equations of lines that we're going to talk about in this class. So we have learned 2 of them so far, and we're going to learn a 3rd one today. Computer away, guys. All right, so the first type that we've learned is standard form. So we sometimes call this general form, standard or general form. So these are the ones where it's like 3x plus 4y equals 12, and then you have to graph it, right? So this is where a, b, and c are integers. A is non-negative. You can't have a negative out front. And we graphed it using the x-intercept and y-intercept method. So we just did that. So can you guys do this one? So it says graph the equation 3x minus 6y equals 12 using the x and y-intercepts. So try it along with me. So if you have 3x minus 6y equals 12, and I'm finding the x-intercept, we plug in 0 for the y. You don't have to write all that, just do it. So when we plug in 0 for the y, remember I said it's kind of like you cover up the y, it's gone. So when we cover up the y value, we get 3x equals 12, so what's x? So we write it as a point. We plugged in 0 for the y, and when we did, we got a 4 for the x, so it's 4 comma 0. So when I plot that, I go over 1, 2, 3, 4. I have that point. I also need to find the next point, y-intercept, because I need 2 points in order to graph a line. So the y-intercept, we plug in 0 for the x, so some of you guys are finding it already. So you said you have negative 6y equals 12, so y equals what? Negative 2. So it's going to be what point? 0 comma negative 2. You plugged in 0 for the x and got a y value of negative 2. So 0, negative 2. And then we just graph our line. Okay, so that's a pretty straightforward way. I think you guys like that method, right?
Yes.
Okay, so we like when it's in standard form. But sometimes it is kind of hard. I mean, how do you graph something that's like 3x plus 4y equals 5? Is that easy? No, because we want things to be like multiples of 3 and 4, right? It's a little tricky when you do get numbers that come out to be decimals. So in that case, I would probably solve for y. All right, so that first one is called standard form or general form. All right, the second kind is slope-intercept form, and we like this one as well. So it's when in the form y equals mx plus b, m is the slope, b is the y-intercept. That's why we call it slope-intercept form. We have the slope and the intercept. So it says graph the equation y equals, oh, I forgot my x, and you guys kept doing that earlier. So it's negative 3/4 x plus 5, right? Can't believe I did that, jeez. All right, so I'm going to start out with my starting point. This is the y-intercept. That's our b value, right? So b starts up at 1, 2, 3, 4, 5. And then my slope is negative 3/4, so I go down 1, 2, 3 over 1, 2, 3, 4. I want to make sure that it's negative in the end. In other words, it's going downwards. Does this one go downwards? Yeah. As you read like a book, left to right. Oops, I missed it. All right, so that's our line. All right, we feel comfortable with those, right? Thumbs up, everybody feels good? All right, so the last one that we're gonna learn is called point slope form. Now, if you don't like this form, that is totally fine. You can do exactly what we were doing today with y equals mx plus b. But I will say there is an advantage to learning this form because you use it, especially if you go on to like AP calculus. We use it all the time. Okay, so point slope form. It says this is used when we have a point and a slope. So don't stress if you can't memorize it. You can always do y equals mx plus b. So here's what it looks like. It's y minus y1 equals m times x minus x1. So this is very similar to our slope formula, which was y2 minus y1 over x2 minus x1. Do you guys see how these are similar to each other? I mean, we have the subscripts. But what if I took this denominator and I multiplied it to the other side? Would they be almost exactly the same then? Do you guys see it? So it's similar to the slope formula. All right, so this is an important one to know. Okay, so when do we use this? Well, think about it. What's it called? Point slope form, right? So we use this when we have a point, not the intercept, any point, and the slope. Okay, so we still need the slope, but if we have any other point with it.
Is that then the relation it is between 0 and the point?
It will find the y-intercept. Yeah. Okay, so this is number 3. I didn't say like number 3. This is the third way of doing this. All right, so number 1, so find the equation of the line through negative 2 comma negative 3 with a slope of 6. Simplify down to slope-intercept form. So we're going to go ahead and use this point slope form. So if I started out with y minus y1 equals m times x minus x1, then it tells me my slope was 6, and this point is going to be my x1, y1. Okay? So I'm going to plug in x1 as negative 2, so I'm going to have x minus a negative 2 And then y1 is negative 3, so it's going to be y minus a negative 3. Did you guys see I plugged it in for x1 and y1? So we have y plus 3 equals 6 times x plus 2. Ryan, you look like you're up to no good.
Is this going to be our test?
Keep looking at me.
I'm not
Like you should
updating
watch.
you.
This is gonna be our test.
It's okay. You can always do the other way, and I'll show you the other way too.
Yeah, I'm not updating. This is.
All right. So this is one way, like, that's nice in AP Calc, like you can leave your answer like that. So it's nice when you can just kind of leave it like that. But in this case, I said simplify down to slope-intercept form because we want to see how to graph this, right? So we're going to go ahead and distribute our 6 in. So we get 6x plus 12. And then we're going to subtract the 3 from both sides. So our final answer would be y equals 6x plus 9. Okay. So math teachers kind of like this one because a lot of times Algebra 1 students will find b, and then you don't like write the final answer. You just are like, oh, m equals this, b equals this, but you never like write the equation of the line. You just get to that point where you found both of them. So this one, at least you like have an equation in the end, okay? So let's try it again. So it says write the equation of the line through the points negative 2, 5, and negative 3, 8 in 2 different ways. So here are our points. So first we're going to find the slope. Do you guys remember the formula to find slope? Not y squared, right? y2, y subscript 2, minus y1, x subscript 2 minus x1. So y2 minus y1 over x2 minus x1. AJ, put it away. So I'm going to have 8 minus 5. Those are my y values. You guys see it? 8 minus 5. And then I'm going to have negative 3 minus a negative 2. Be careful with your signs. Negative 3 minus a negative 2. I get 3 on top. But what I get on the bottom, it becomes negative 3 plus 2. Negative 3 plus 2 is negative 1. So we get negative 3. So the instructions say go ahead and use slope-intercept form. We're not going to use the point-slope form. So we're going to do it just like we were doing before we started this. So let's do our y equals mx plus b. And we know that our m is replaced with negative 3. We're going to temporarily replace our x and our y with either of those points. It doesn't matter. So how about this table you guys do the first point, negative 2, 5. The back table you guys do negative 2, 5. These two tables go ahead and do negative 3, 8. Let's see if we get the same thing. So when I plugged in my point, I got a b value of negative 1. Did you guys all get a b value of negative 1? Yeah? Did you guys get a b value of negative 1? Yeah? No? Okay, so do you want to do the other one? So if I plug in 5 and negative 2, like that, 5 equals negative 3 times negative 2 plus b, I get 5 equals 6 plus b. And then if I subtract the 6, see how I get negative 1?
Oh, yeah.
Yeah, so I have b is equal to negative 1. So I have my m and my b, so it's y equals negative 3x minus 1. Done. Okay, so what I was saying is that a lot of students will just stop there and they'll be like, oh, I found b, but then they don't do this final step where they write the equation. Okay, so the second method, use point-slope form and simplify down to slope-intercept. So you would start out the same way. You'd start out by finding the slope. So you do your 8 minus 5 over negative 3 minus a negative 2. So you would still get negative 3. So the first step would be exactly the same. But now you would do your y minus y1 equals m times x minus x1. And you would plug in your slope, negative 3, and either point. So let's say I plug in the negative 2, 5. It would be x minus a negative 2, and it'd be y minus 5 on the left. So I get negative 3x, and well, let me do negative 3 and then x plus 2 in parentheses. And I'm going to distribute. Ryan, how about you move? Go to that table. So I'm going to distribute n. So I get negative 3x minus 6. And then when I add the 5 over, I get y equals negative 3x minus 1. Do you guys see how it's exactly the same answer? Okay, so why do math teachers like this? Because you actually get the final answer of y equals something. Like, a lot of people just leave the b equals. Okay?
Wait. I thought it was a negative 2.
It was minus a negative 2, so it would be plus 2. Yeah, there were two signs in there. Do you see it? Minus a negative 2. All right, so that's the second method. All right, so do what you're comfortable with. So Peter was saying, do I have to know this for the quiz on Friday? No, you can do y equals mx plus b. That is totally fine.
I thought it was next Friday.
The quiz is this Friday. The test is next Friday. All right, so the reason it is nice is, can you imagine, like, if you were in AP Calc and I said, oh, find the equation of a line with a slope of negative 31 over 17, and it goes through the point negative 35 over 67, comma, 53 over 91. Can you imagine? So that's why we would do the y minus y1 equals m times x minus x1, because we can just leave it in that form. We can write negative 31 over 17, x minus an x1, so plus 35 over 67, and then y minus 53 over 91. So there is a whole point, like there's a reason why teachers teach you this form, right? But for you right now, it's not really like super important that you know this, okay? So don't freak out if you can't memorize it and you have trouble with this. All right. So let's do the last one. So Monopoly. Did you guys know Monopoly is based on linear functions? Yeah. So in the game of Monopoly, if a player lands on a property owned by someone else, they must pay rent to the owner. So the rent can be modeled by a linear function of the selling price, for the most part. They're not going to be like, you owe $20.18. Okay, that's kind of weird. So they kind of round up or round down.
Always wind up being.
You do. You must be good with numbers. All right, so we know this. We know that when we land on Park Place or Boardwalk, we owe more rent, right? That's why we want those. Even though they're more expensive, we get more money when people land on them, okay? So it says, express the rent as a function of the selling price. Oh, goodness, it got shifted over. That goes over there. So express the rent as a function of the selling price. So in other words, I want to have my rent be y and my selling price be x, and I want to write an equation of a line. So these are all points. I have the point 60, comma 2. I have the point 100, comma 6. I have 180, comma 14, and so on. So when it says express the rent as a function of the selling price, all it's saying is write the equation of the line through any of these points. So pick two of the points. Do you guys want to pick the ones with the smallest numbers?
Yeah.
Probably, right? So we're going to pick 60, comma 2, and we're going to pick 100, comma 6, and we're going to find the equation of the line. So we're going to do m equals 6 minus 2 all over 100 minus 60. So I get 4 over 40, which is 1 over 10, right, if it reduces down. That's my slope.
Could you slow down a little bit?
Yep. Sorry. So that's your slope. We don't have the y-intercept, right? We don't have any point that says 0, comma whatever. It wouldn't make sense to have a 0 for your selling price. Okay, so we're going to use either point. So let's say I set up my y equals mx plus b, and I'm replacing my m with my slope. So my m is being replaced by 1 over 10. We can plug in any point that we want for our x and our y. So let's say we replace them with 60 and 2. So if we do that, we would have 2 equals 1 over 10 times 60 plus b. Yeah, what's 60 over 10? 60 over 10? 6, right? So 2 equals 6 plus b. Sorry, I know b's look like 6's. Mine are not very good. I'm trying. You can always do a capital B if you want to as well. So subtract 6, I get negative 4 equals b. So my final equation is y equals 1/10 x minus 4. So part B says, well, based on this line that we just found, this equation of a line, how much would the rent for Illinois Avenue be if it sells for $240? So if you're selling for $240, am I going to plug in $240 for X or for Y? Look at your chart. for x, right? Do you guys see how the selling prices were the x?
Oh, yeah.
So that means if I have my equation, y equals 1 over 10 x minus 4, I'm going to plug in $240 for x, right? And that's going to find the rent for Illinois Avenue. So I have y equals 1/10 times 240 minus 4. What's 1/10 of 240? 24 minus 4. So what should the rent be when you land on Illinois? $20. I don't know if that's what it actually is. Is that what it is? Do we know? It's not. All right, does this all make sense? Do you guys get it?
It makes more sense now than it did before.
Okay, so you guys feel pretty good about the review we did at the beginning? Okay. All right, let's stop here.